live. Welcome, Sahil. Welcome to the Engineering Unplugged podcast. Let me quickly introduce Sahil. Sahil is from NIT Trichy. He then went on to work at GS. He realized he wants to do something in finance and did his master's from IIM Calcutta. Worked at Merryl, Lynch and Bank of America for some time and realized that trading is not what he wants to do. And since then, he has been a hacker. He has founded multiple companies. And since last 7 years, he's building GMetri, which is a startup in the Web3 Metaverse space. You want to talk about that more, Sahil?
Sure, Bhavin. Thanks for the kind intro. So GMetri is a no-code metaverse toolkit that allows anyone to, using a drag and drop editor, create their own metaverses. These metaverses can be for any use case that you can think of. It can be for e-commerce. It can be for employee interactivity. It can be for training your employees on certain aspects, right? So any metaverse that you can think of, you can build on GMetri without having to code at all. So that is GMetri. I'll just give a very quick intro of GMetri by just sharing my screen quickly.
Yeah. Please don't skip this demo. This demo of 2.5 minutes is crucial to understand the technical context of the conversation in the rest of the podcast. We talk about various software and infrastructure problems faced by GMetri. During the demo, try and visualize the backend system that is going to serve this metaverse in a browser.
This is GMetri, what you see on the screen right now. There's a 3D space where you can walk around. I'm just going to third person mode, right? And these are the three main use cases that enterprises are using GMetri for currently: employee experience metaverse, digital twins, and e-commerce metaverse. And what GMetri essentially gives you is the ability to create an interactive experience like this, where you can have simple rules where you can say stuff like, when I come near a person, let him invite me. Or you can create AI brains for certain metaverse characters where you can feed them a knowledge base and they essentially act like a chatbot when you come near them. So GMetri platform in a nutshell is basically three things. It allows you to create metaverse experiences in a few minutes. It allows you to publish them and deploy them on the web using a simple URL, kind of like WordPress or Canva. And it also gives you out of the box analytics, right? And coming over here, you will see a few of the experiences that are live with our customers right now. So here you see an experience where this company uses it for employee onboarding. You choose your own buddy and you are taken through all of the leaders in the company, and they tell you about the kind of stuff that they work on. Here you have a digital twin metaverse where a live factory is connected with its IoT devices. Here you have a training simulation where you are brought inside a factory and you learn how to create certain drugs, certain chemicals. This is basically a kind of a pavilion where employees are introduced to various parts of a company, the various departments of a company. And essentially the whole idea of a metaverse experience is it's self-exploration. So you are in a space and you can go by your own pace, slowly, and you can go as deep as you want in whatever topic as you want. So it's a really nice thing for a company to have, where you have one space as the starting point and you keep on building deeper and deeper and deeper as time goes by. So that's the advantage of GMetri. And all of this is built in an editor like this, where you just come in, create a project, drag and drop stuff, and write the rules around it. All no code, all single click publishing. So that was a really quick intro of GMetri. Over to you.
Awesome. So in one line, this is a no-code, low-code solution to build your own metaverse. And you can, I assume you can create assets into it, and you can upload videos, and you can, as you said, you can build the rooms and then add navigability. How does the tech look like? Let's dive one level deeper. So can you give a quick intro to how the architecture looks like, and what are some of the very sticky tech problems that you have attacked in the past?
Sticky tech problems, it's a long list. So first let's go through the architecture. So it's a simple architecture, front end, back end. Front end is managed mostly by this library called 3JS, and we have built a lot of stuff on top of 3JS to be able to build really quickly. Backend is mostly Node.js with a bit of Python here and there, but mostly Node.js, and we try to stick to TypeScript as much as possible, because when you're maintaining such a huge code base, you need strict types. Having the freedom of JavaScript can work against you for large projects. So even almost all of our front end is TypeScript. Backend too is all TypeScript, and where we needed Python, it is Python. Yeah, so that's the architecture mostly. And for deployment, we use Docker and Kubernetes.
Where do you store stuff? All of these assets?
Yeah, so that's a pretty interesting question. So when we started out, we were storing it in S3, right? But S3 has its own inherent problems where, we had given a nice UI to our customers to be able to look at the listings in S3. But it turns out S3 API calls take 300 milliseconds or 500 milliseconds. So it's like working on a really old laptop. You click on something, you wait for some time, have patience, then it opens. Then you again click on something, you have patience. So that really didn't work. So we had to build our own backend for it. That was a pretty tough call at the time for the business because our business was just taking off. We had customers with us, but we had to solve this problem because we knew that if we have to survive for the next couple of years, we need a really fast API. We need a really fast UI for people to be able to create this stuff. And we had projects with thousands of assets in a single scene. Like people keep adding images, people keep adding audios, people keep adding videos.
So at what scale did this break down?
Yeah.
Did S3 stop working for you?
So S3, the list API of S3 works well with 10 objects. The moment you hit 100, you start seeing the slowdown. You start feeling something is wrong because you click on a folder and then you wait for around a second for the API call to come back because you're not talking to S3 directly. You're talking to it via our server. So the call comes to us, we talk to S3, we get back and we do it. So we finally, to solve this problem, we ended up creating our own virtual file system. So we reduced the number of calls to S3 drastically. The only thing that we do with S3 is store stuff and get stuff. That's it. The file system is all virtual. The file system is all fantasy on a Postgres database. That's it. So move operations, cut, paste operations, all of them are like a single millisecond operation. So it became instantaneous. So it had a huge benefit, but it had a huge cost also. It had a huge temporary cost. Right? We had to stop our normal way of working. We had to solve.
Yeah.
We had to say, okay, all of these other tech problems, baad mein. Leave it. Let's focus on this singular problem and solve it for now because we know that eventually we will reap enough benefit from it. We will save enough time from it to make sense out of it. And this was, I think, 5 to 6 years back. So definitely it has made sense. And we did a search. It is not like we want to build stuff blindly. So we are very, very careful about the stuff we build. We really do not want to build stuff which is out there for free in the open source world.
Yeah.
Never, right? Because if it's there in open source, they've probably spent a lot more time, they've spent a lot more sweat on it than you would ever do, right? So it's always good to use stuff in the open source world. This was one specific instance of a problem which did not occur in the open source world. There was no solution for it. So we built it from scratch. We took three months out and then we implemented it.
So S3 was good at storage, but it was not good at the file system operations, which is listing files, moving files, etc., etc. And the whole file table, you basically extracted out of, like, S3 was not responsible for it, and your own VFS layer was responsible for it. So this was what, a simple like relational database?
It's a simple relational database, right? But the thing is, if you're creating something like a file system, it better be extremely robust. Any single mistake you do there, it's going to bite you in the back. Debugging it will be a nightmare. So we built it extremely carefully. We built it layers on layers on layers on top of layer. We took our time building it. It wasn't a very rushed thing that we need to do it in a week. No, it was not that.
Can you take an example? Like, what kind of robustness? Can you take an example of where it would not be robust if you didn't build it? Like, what kind of edge cases?
So the edge cases are things like, let's say you have a folder with 1 lakh files, right? Does the cut paste operation take 1 millisecond? Or because it has 1 lakh files, does it take 1 second, right?
Big of n or lesser than that.
So we have to make sure that every single operation is either order of 1 or order of n. You cannot go beyond that.
Okay.
Right. And it was more of a mental math. We did not have the time to, write a test case to ensure that there was robustness at that level. Sorry, we did not do that. But yeah, we read through the whole code base probably 5 times. And before writing the code base, we hammered our brains on the architecture diagram like 5 to 10 times before even writing a single piece of code. So yeah, it was a well thought of product. And
But what gave you the confidence that this is going to work? Did you do some load test? Like, did you actually run it with a case with 1 lakh or maybe a million files?
nothing.
Or not really? It was just review at the design level.
Like we knew the stuff that is fast. We knew Node.js is okay. We know that it is not as fast as Python. Yes, we know Node.js has its limitations, but yeah, we know that if you make a call to a server, you're supposed to get back the response in like 10 milliseconds. It should not take more than that,
Hmm.
right? And that is instantaneous for the human eye. We are happy with 10 milliseconds. And therefore, the amount of stuff that Node.js does, you probably have just 1 or 2 milliseconds for it. You cannot spend more time than that. So our restriction was everything that we do should happen within a millisecond or 2 milliseconds at best, right? And it has to be order of n or order of 1 so that it never reaches 10 milliseconds, for example, or 20 milliseconds. That was our benchmark. Whatever you do has to be within 1 or 2 milliseconds. So we just went through the whole code base again and again, made sure that every single operation that we could possibly perform on a file system, everything is extremely simple
Right.
on the database, right? And we also made sure that the data, it was Postgres. So kitna, a billion rows, we are good till then, right? So it's
Yeah, very
not about
easily.
we have it yet. So we'll think about that later.
How difficult was it to actually figure out that, oh, S3 is really the limitation and we have to build something custom? As you said, you took 3 months to build it, and it was significant bandwidth consumption that went into building the solution. So, how did that decision making go? Can you talk about that? Was it just you who decided? Um,
So it all started out with the tech team, obviously. So we built the product, we were happy with it. Fine, yes, we have a UI where you can see your files. Yes, you
yeah,
can drag and drop your files, it uploads. We were so happy with it, right? And we shipped it. And we told our clients use it. Everyone was happy with it for around 3 to 4 months. Then that is when customers start expecting more, right?
yeah,
Yeah, a folder move is taking a long time. Yeah, this is taking a long time, right? And we know, yeah, of course it takes time. It's S3, you are sending so many operations to S3, it will take time. So for us, we didn't care about our time as a typical tech team. And then slowly we realized, nahi, everyone expects more. And then we started taking more and more because more and more complaints started pouring in, right? And
right.
at a point, it became so bad that even we felt that on the larger projects, even our internal teams weren't able to, work on the editor because it had thousands of files. And the moment you have thousands of files, the UI literally just hangs. You double click, you wait. Again, you double click and wait. And that was a point we realized that if we need to make this a global platform, we expect every school to use this. We expect every company to use this internally. This cannot be the UI for them. It is just impossible. We have to solve it. So, and it was fairly obvious that the problem is S3. S3 is great for storage. It is meant for storage. It is not meant for a file system.
Yeah,
We didn't build S3 for this solution. We were just reusing it for it like a shortcut, right? It was our fault for using S3 like that. We did a lot of search online. Is there a way to prevent 3 months of work or 6 months of work trying to solve this? Because you don't want to be wasting resources in a startup. Our time
yeah,
was extremely precious. Unfortunately, I think we searched for a good 2 weeks to 1 month. Unfortunately, we did not find anything. We talked to a lot of people also, and none of them had hit the problem like us. We were expected कि अच्छा, if I drag and drop an image तो हो जाएगा. We were also expected कि if the image is, let's say, 4,000 pixels into 8,000 pixels,
hmm.
our platform should be able to handle it. The thing is, if you open that image on Chrome, your Chrome would crash today.
Oh, even today it would crash.
Yeah, I'll give you a large image. Your Chrome, you will run out of video memory buffer and your Chrome will crash, right? There is a limitation to the asset size that our browsers can open, which makes sense because all the pixels go to a graphic card. Graphic card has limited amount of memory. So we were also expected that all of these assets would be downsized. So we needed a really robust system
Hmm.
where we had a really good idea of what assets are there in a project. Everyone had the architecture in mind. This is what we all learn in computer science, right? We learn trees,
Yeah.
we learn file systems. So the answer is fairly obvious, but actually building it and making sure it works and works in a robust way and doesn't fail, that was a real challenge here. And I think
Hmm.
once the whole team understood the architecture, right? Once everyone was on board with the architecture and understood why we are writing these layers, what were the problems that could have occurred if we skip a layer, right? Once everyone understood that, the code base for it was surprisingly simple. It is literally some I don't know, 10 files or something, 10 large files, but that was it. We have built a lot of stuff on top of it. Like when you upload something, we run migrations on it, making sure we have a low res image, we have a high res image. When you upload a video, you can do stuff with it. You can do video processing, we do audio processing. We do a lot of stuff now. So we are able to build a lot of pipelines because of that virtual file system, because we know what is there in our system. Earlier, it was we used to ask S3, hey, what is there in this folder? Can you tell me? Right. And so, yeah, short term pain, right? But long term, it definitely yields a lot of benefit.
I also assume that you didn't have any monitoring on that. How long is it taking to move a folder?
Yeah.
Maybe weighted by its size, and then you build the VFS.
Yeah.
Now, do you have monitoring, or like it's not worth it because now the solution is obviously so fast
Yeah.
that it's not worth monitoring?
Yeah. So now, let's say you are moving a folder from one place to another. It is one integer change, one column change. So the amount of time it takes for us to do that is one update query in Postgres,
Yeah.
where ID is something. So we know that ID is always indexed. So all of our operations are on IDs. It has to be order of one. It has now we're depending on the C++ code that the guys in Postgres have written. Right? We are
And did the latency problems just completely go away? The customers who were complaining about कि folder move करने में
Yeah.
time लग रहा है, did it completely get resolved?
Yeah. So this specific instance, yes, latency problems are something that stick with you if you have a global platform. You cannot get rid of it, unfortunately. But yeah, in this instance, it completely solved. So one thing that no one can overcome, whether you are Google or Microsoft or whatever, is the speed of light. So if you're sitting in US and you have data in India, it will take 300 milliseconds. You cannot make it faster than that. You can make it, I think, till 200 milliseconds with a better fiber optic cable, but that is the limit. So yeah, that is a latency problem we still deal with. When we started out, right, we had a lot of customers in India. We obviously wanted to grow our US base. We had success. We had initial success there. But very soon we hit upon a problem where everyone started complaining, yeah, your experiences load really slow. Okay. And this was a complaint only from US, not from India. Right. And one problem we definitely faced was, okay, how do we replicate it? Okay. We figured out, okay, this is a problem happening from US. Probably VPNs is the solution. Let's use VPN and try to figure out what's really happening. Pretty soon, very soon, within a day, we realized, okay, problem is latency. There are a lot of calls that happen between India and US, and we really can't do much to make it faster than this unless we think of a re-architecture. There were a lot of times we pushed this problem under the rug because we never had the resources or the time to even think about it. When I think around 6 months down the line, when from the time that it was first reported, it became very serious, and the other co-founder Usav, right, he is the one who talks to most of the clients. He said, "Nahi, now is the time we take out time and we fix this. We really need to think of a solution." You will find a lot of databases and, for example, even Redis claiming that they have solved the problem. You will find, and no matter how many CTOs you talk to, right, all of them have a different approach to this. So there is no clear-cut answer to this problem. So what I realize is the problem has to be geometry specific. The solution has to be geometry specific. I will not be able to copy someone. For example, our operations are asset heavy, unfortunately, right? We make a use of a lot of CDNs. Our code runs mostly on the browser, right? So we need to make sure our code reaches the browser as soon as possible. So it kicks off and it seems that it is fast. So a lot of the architectural decisions in Geometry as a VR platform were different from anything else that we have seen out there. I actually talked to one of the CTOs of Wipro. I talked to one of the CTOs of TCS. I talked to a lot of people before deciding what to do here. I talked to Alagu also, by the way, Alagu and our whole internal Delta group, trying to see what other people have done before.
Yeah.
The solution that mostly people employ is kind of like sharding, right? And teaching your code base that if the call is from US, do this, but if the call is from India, do that. The problems that I found with this solution was you need a large team to support it. So we were a team of 4 to 5 developers at the time. Everyone was extremely burdened with a lot of other tasks. So the problem with that solution is the whole team needs to be in on it, right? It wasn't something you could do in 2 or 3 weeks time. So out. Then if you couldn't do sharding, then the other solution is caching, right? Now with caching, even if you have local caching, right? Generally the cache solution that I got was people do everything on cache. Like the storage is also cache, everything is Redis, right? It's kind of having 2 different databases in 2 different regions with 2 different code bases. Our problem was look, we are going to have metaverses where there are two people from China, two people from India, and two people from Australia conversing with each other. Okay, and one guy from US. We cannot have completely separate instances. There needs to be one common source of truth. This was a problem not many other companies were faced with. So we needed one commonality. So we cannot escape the fact that there will be one master Redis or one master Postgres, some place where the single source of truth will be there, right? And that was a huge problem that we had to work around. So the final solution that we came up with was a mix and match of everything that we learned from others. We have a local cache, we have a central cache, right? And we have mechanisms to make sure that a lot of communication happens between the two. So everyone feels it fast. But the actual data updation in the central cache happens after a bit of delay, let's say 1 second. But no one gets to know that. Right? So everyone feels it fast now. Everyone feels it loads really fast because so for loading, we have extremely aggressive caching at the edge Kubernetes clusters. And for communication, we have a different kind of caching with the central layer. So for different problems in geometry, we have to come up with very different forms of caching. And this was finally a solution we were able to implement in 2 to 3 weeks, right? All of the other solutions that we heard, unfortunately, required a very big rewrite. And we never have the time or the money to spend on that, nor will we have, right? And even if we had done that, we wouldn't have been able to manage it properly. There would be just too many bugs and just too many issues with it. So we said, okay, we'll come up with a compromise. Just write one layer that caches extremely aggressively locally and does a look ahead later. Basically, first serve the customer and then see, hey, was there any update? If there's an update, okay, fine, update the local cache, fine. And that was a compromise that we are able to live with because not too many updates happen. So if an editor edits a project once a week, there are probably a lakh views that are supposed to happen with that one edit. So the views are a lot more than the edit. So we are okay with those compromises. So the compromises that you take for your solution has to be very specific to your platform, right? So especially latency. So that is one problem that I found that there's no good solution out there.
What were some of the other sticky problems that you ran into where you have taken unconventional decisions?
So geometry is a story of all unconventional decisions. One of the things that we started out with definitely was initially when we started out, for a long time we were bootstrapped. We didn't have any money. We were running on fumes, almost zero salary as founders, and our initial employees were very supportive. So yeah, things were okay. We were just going through, and luckily we had money coming in from customers. But again, we had to be extremely conservative. Our biggest cost at that time was just hosting our services on something like either AWS or Google. The cost constraints were what drove us to things like Kubernetes, because that allows you to really be efficient with the number of cores you have bought from Google or the number of cores that you have bought from AWS, and you keep reusing the cores which are not used with other Docker containers, right?
Yes.
So a lot of our solutions were based on economy. What we realized was we were spending a lot of money on things like our chat platform, our Git, our Docker, our file hosting services like Dropbox. It turned out that the bill for all of these things was coming to around $1,000 or $2,000 per month. Like that is a lot, really a lot for us at that time. So we said, okay, we had at that time, not now, by the way, I was a big proponent of let's have desktops. Okay, desktops are fast, they're cheap, and you can upgrade them, and it's easy to buy graphic cards for desktop. And we are a graphic card heavy company, obviously the Metaverse. So let's put a desktop route. This was 2017. So we did have a lot of desktops. And very soon we reached a point where when I'm looking in the office, I'm looking at here, okay, so we have these 3 desktops not being used. And I'm giving this much money to Google or AWS for hosting my chat service or hosting my Git service.
Yes.
Why? Not done. This is just not done. Everyone is in the office and we are paying them. And at the same time, we had a company to run. This was all my personal fantasy, but yeah, we had a company to run, so we couldn't spend too much time on these things also.
Right.
But one particular use case we had was we needed a Kubernetes cluster to test our code. You need a Kubernetes cluster. One Kubernetes cluster costs, I think the cheapest one you can buy is 50,000 rupees per month. It's not cheap, right? We did a little bit of search online and we found a solution called Rancher. Rancher kya karta hai? It allows you to create a Kubernetes clusters on bare metal. So we connected all of them, add a router, and very soon we had a Kubernetes cluster on the 3 desktops computers which are there. Our code was running on it beautifully, and probably 10 times faster than what we had on AWS. because AWS gives you virtual cores. These were actual cores. These were like dedicated to you. This is as fast as it gets.
Yeah.
And we were very happy with it. That took us down. So that was just a trigger. And that took us down a journey where we said, okay, yeah, this is a really good solution. A lot of money like this. So again, we did a bit of research online. We mixed a few blogs here and there, did a few YouTube video searches. Then turns out there was a company called Server Basket that gives you second-hand servers. Okay, these are second-hand servers with like 128 cores, 256 cores, humongous number of cores for 1 lakh, 2 lakh. Okay, so we bought one of those machines.
Wow.
Yeah,
That's like super cheap.
exactly. It looks cheap, right? But that is the actual price. That is what we are paying for to AWS.
Yeah.
That's how they are paying their employees, right?
Hmm.
So these are servers which are discarded by AWS or Google. That's why they are this cheap. They bought it for 10 lakh and now they're selling it for 2 lakh, right?
Hmm.
But they're working fine. Just that they went on to the next generation. For us, it's more than enough. We took those servers. We installed the free version of Proxmox on it that allows you to do virtualization and all.
Yes.
And we ran our Git, Docker, chat,
So
NX,
everything is self-hosted now.
everything you can think of, we moved there in a matter of like 1 or 2 weeks. Okay, and it's running in our office. So our cost came down drastically. The service quality went up. So service quality was a mixed bag because internet connectivity was an issue, but the speeds that we were getting were phenomenal, just phenomenal.
So
Right.
was this just your office workflows and staging, etc., that was on your personal cluster, or was your production also moved to your personal cluster?
So we never had the heart or the courage to move production to personal cluster. And
Okay.
you can't because a
You
lot of
can't.
the customers ask you, ki, where is it hosted? Are there enough security measures and all
Yeah.
around it? So we had to stick with a proper production workflow.
Yeah.
It was mostly on GCP or AWS at the time.
Okay.
And, but yeah, for our personal stuff, for our testing stuff, for internal chat, things that don't matter so much,
Hmm.
that we moved to our own server. And we were like, yeah, this is really good. And we never imagined things could be so fast. We are used to slow services from whenever we self-host online, right? This was,
Yeah.
this was light speed. This was really good. And then because we had so much free computing power, we're like, okay, why not give every developer a personal VM? So that's what we did. So every developer in Geometry has a personal VM of around 8 to 16 cores,
Mm-hmm.
some 32 GB RAM that is dedicated to him. Do what you want, right? So all of our development, so Geometry at once, if you run, it requires some 16 different repos to be running at the same time, right?
Okay.
If you're not running everything, if you're running the cut down version, it's 16 repos with the different parts of services because it's kind of a microservices architecture. There is one
Cut down. You're
uh,
saying cut down version is 16
it's a
repos.
cut down. This is without the AI bit. We have another few repos for AI now.
Okay.
So, but yeah, it's more or less established. We have a script that starts everything. It's fine. The only problem is it requires some RAM, right?
Yeah.
If you run it on your laptop, it cannot be run on an 8 GB laptop. You probably need a 16 GB laptop to run it.
Correct.
That was the limitation that we have. This limitation went away because everyone has their own personal VM with 32 GB of RAM for free. We just use VS Code SSH. Everything runs there and everyone is happy, right? So these were just some of the side benefits we were getting for free. Now everyone could run their own personal instance of Geometry. Yes, yes, sahi hai, karo. In watch mode. I'm talking about watch mode, not running.
So just curious, where was the cost in terms of Docker and GitHub? Like GitHub is free. Docker, you can just host in public
Yeah.
Docker. So where was the cost?
So Docker, the decision to move Docker in that server was not cost. Docker isn't costly. The storage that AWS provides for Docker is cheap. I think
Yeah,
it's
it's like,
ECR,
yeah,
right?
super cheap.
Elastic Container something.
ECR,
ECR
Elastic Container Registry.
registry.
Yeah.
We could use that, but the thing is, our builds. Obviously, when we have a server, we move our build system there, right?
Hmm.
We have so much CPU, bare computing power. Obviously, if I run it on AWS or Google, I will get charged a bomb. Now I have put what 16 cores, go build, right? And it's instantaneous almost, our builds.
Hmm.
So,
Oh, so because your builds are local, and
yes,
if your
these
Dockers
require
were,
Dockers. All
then
of
you
the
would incur
communication that
bandwidth.
happens now is local. So even if I'm downloading a 500 MB Docker image, it's like super fast because in the same network. These
Yeah.
VMs are brothers and sisters of each other running on the same CPU, right? communication हो गया, internet, there's no network involved, हो गया, done, Docker Docker downloaded, build done. Final push also happens here, right? And our production server gets our images from here, and that's it. And now, of course, we have matured the whole system a lot. Now we have 3 servers. It's no longer running in our office. It's in a data center, next gen data center, where kind of out of Bangalore. But yeah, it's with proper power backup. It's a very resilient system now. We have 3 servers for backup of each other, and we get the cost benefits out of it like crazy. Probably we are spending 1/5 of what we would have spent had we hosted it outside. So you get the cost benefit over the long term, and you get the speed benefits instantaneously. And there's something I think when we had started off, everyone was against us. "Ki kya karo? Why are you wasting time on this?" Because we did waste time. I agree, it is not a zero effort thing. I
Yeah.
agree there are a lot of learnings along the way. We did a lot of stuff that is not there out on the internet. We had to patch a lot of things, discover a lot of things, read a lot of guides on our own, and then figure out how to do it. But yeah, when I say we, it was mostly me who was spending time on it. So the rest of the team was not impacted by it. But yeah, I think it was a one-time effort that we had put. And now I don't even look at it. Like I don't remember doing anything on it over the last 3 to 4 years. It's just on auto mode. It's running. Right? There's not much to do. Like I'm probably spending one day in a month or half a day in a month to look after it. Right? Whenever there are upgrades or anything like that.
Right.
And that's about it. And the benefits we are getting economically are huge. Right? So everyone was against it. Ki why use your own servers? Who does that? Everyone has forgotten that is how the computing world started.
Yes.
Right. That is what you are paying for in the cloud. The cloud is what? It's servers. It's not cloud, it's servers. You are cutting down the VM yourself. So,
Yeah. And it's such a big illusion, right? That once you move to cloud, everything is going to be cheap, but it's cheap only when you are at super low scale. If you are a single developer doing something silly, the moment you hit a little bit of real scale, the costs
yeah,
are,
the costs are astronomical. Yeah. So
yeah,
our Kubernetes costs right now are huge. For me, the ability to host a Kubernetes server for literally no cost is a big benefit.
So where is this data center hosted? Is this like some managed space where you can
Yeah.
rent a rack and
Yeah.
uh,
So it's a proper data center now that we are hosting it in. We use this service called NextGen. NextGen
okay.
is a company I think owned by Intel, and a lot I think Flipkart has a complete, not maybe not complete, but a lot of the hosting on NextGen servers.
Hmm.
They're a proper company with a huge data center. Like it's on the top of a hill, so even if it floods, it doesn't. The data center is not underwater.
Wow.
Multiple power backups. It's a, I don't know, probably half a kilometer across half a kilometer, huge area cut into multiple server racks with crazy amount of security. So a lot of production servers run there for a lot of serious companies, for a lot of banks. And what we're renting from them is just power and internet.
Hmm. And
That is what
space.
we pay them for, and space and rack space, right? It's our own servers. What was running in our office, we just shifted there and done.
Don't you have issues of the hardware failures? Like hard disks fail all the time. The servers, which are used ones, which you have bought from, first party, will also fail at some point. So, what has been the experience on in that space?
Yeah. So for us, we have been running 8 multiplied by 3. We've been running 24 SSDs, most of them of 1 terabyte or 2 terabyte. I think we have one SSD of 4 terabyte. Till date,
These
over
first
the
hand?
last,
Are these first hand? I assume
SSDs are
so.
first hand. SSDs are first hand.
Okay.
We didn't even go for those enterprise SSDs which are 3 times the cost. Sorry, we just bought it on Amazon. Our SSDs, they work fine. Okay,
Hmm.
not the 860 QVO. We went for the EVO that is meant for enterprise use, enterprise-ish use, not meant for rack servers, but we are still using it. It's fine.
Hmm.
Till date, only one SSD has failed. Okay, over the last 6 years. Okay, and what we have done is our critical services run on a ZFS.
Yeah.
Because it's a ZFS, I have a margin of error of 2 SSDs.
Right.
Okay, so even if one fails, I have time to go to the data center and change it.
And does the service do it for you, where you can just
They
ship a
also do
SSD
it.
to
They
them and
also do it, but till date, I haven't faced that situation. Jo fail hua tha, I just moved my VMs out of there and it is done.
it's just
It's
sitting
there,
dead
the server is
there?
sitting there. Probably when I go there next, I'll do it. It's there in my to-do list.
Okay.
See, SSD failures are not that common. Hard disk fails, I agree.
Yes.
SSDs don't fail that much. And the thing is, oh yeah, one more learning. I don't know why. People, when you buy a server, people say, do you want this hard disk with it? Why? Don't use hard disk. Just switch to SSDs. It's the same cost nowadays, right? SSD's failure rate is close to none. Very, very low failure rate. So just switch to
Mhm.
SSDs and you are good. And the speeds are phenomenal. The parallel VMs that run on our SSD, we run around per SSD, we are okay with 5 to 6 VMs, active VMs of developers developing on it with watch mode on, right? It's hard work on the SSD. It works fine.
Yeah, and of course, I mean, your builds are going to be faster because your work is also very, very data heavy, disk heavy in terms of assets, etc. So SSDs like pay off a big dividend there.
It's not even payoff. It's the same cost as a hard disk. It's a no-brainer nowadays.
Hmm.
There is no reason left for servers to use hard disk. It is probably legacy reason which remain.
I mean, it can't be a free lunch, right? What I'm trying to understand is that, sure, like you saved on the cloud costs because you set it up and you tasted blood the first time it worked, and then now you're doing everything on your personal data center, self-hosted data center. But there must be some challenges. Like how about software upgrades? How about those patches,
Yeah.
OS upgrades? There must be some thorny side to it, which is not like I'm sure it's net
So,
positive, but what are some of the bad sides to it?
so you need someone who is extremely good at remote management of servers so the way I simplified my whole workflow was using things like Ansible, Terraform, and
Hmm.
so on. So
Hmm.
now the reason I spend so less time on it because everything is Terraformed, right?
Right.
I just have a Terraform script that goes through every server that I have running. If there are any upgrades, I control it through Terraform and Ansible. So I try not to touch the servers myself. And because of these first principles, right, of making sure whatever I do is repeatable, right? I actually agonize a lot in the beginning, trying to make sure I never do something manually on a server, and it is agony, and I go through it every time. The reason I go through it is because of the fruit that I get at the end, which is of repeatability. If it is repeatable, suddenly your future pain goes down, right? And because everything that I've done is repeatable, things are okay. Now, because I'm following these principles, things are easy for me to manage. If you don't follow these principles, if you are a person who is cutting down the VMs on your own, going into the VM, doing
Oh,
sudo apt install MySQL, for example, or Postgres, then no, then don't do it.
yeah.
Every service that I run is Dockerized. Every service. So even our Git is running on a Docker inside a VM, which runs on the service center, right? Even
Hmm.
our Docker repository runs on a Docker repo. The dark side of it, right? It's not all green. Yes, there are more management issues, but yeah, if you can do it, do it. If you can't, and if you think that it's going to take away more than it's going to give you back, then don't do it. Yep.
How do you foresee it? The calculation of how much cost are you going to save versus how much capex are you going to incur right now? How easy was it, the decision to move? I mean, did you have to take a very hard leap of faith? Like, were you scared in the beginning? Um,
Uh, In the beginning, see, it was an experiment. If it worked, it worked. If it failed, it failed. Luckily, we had the building blocks with us. We had the few free desktop machines lying with us. All
yeah.
of them were Ryzen 5 or Ryzen 7. Each of them had 8 to 12 cores, and one of them had 16 cores. So we had semi-powerful machines for that time, right? And we connected them up with LAN wires, and suddenly we had a cluster running on it on this thing called Proxmox. So we
Hmm.
had a test bed with us, and we could see, okay, will this work or not? Was something we could experiment in our office itself. So a lot of the learnings happened in the office. We started using it for our Kubernetes cluster. It actually worked.
Right.
This was all like a 1 week experiment, and when it worked, that is when our heads turned. That is when we said, okay, maybe we can do something more out of it. That is when I did a little more research with a few of my friends. But how do you host stuff? Is this something where you can save money?
Okay,
So
so the takeaway for me is that you did a POC. It
yeah,
was
yeah.
not that you went all in with a lot of
Of
fantasy.
course
Let's
not.
give it a
Yeah, yeah,
whirl.
yeah. This one
So,
like let's spend a lakh and yeah, it'll work, or let's spend 3 lakh. It was a very, very gradual thing. It happened over months. We did something, we stuck with it for a month, working fine, great.
yeah.
Then we thought, okay, let's buy a small server rack for the office. We actually bought a server rack for 20K or 30K for the office, where we put
Hmm.
all when we dumped all the desktop machines. Then I have a video on YouTube on what is the best way to stick a motherboard on a rack? Because the desktop machines take too much space. We actually took the motherboard out, took the SMPS out, and wired everything together. Which tape is the best to stick a motherboard on a metal plate is the research that we had to do.
Oh, I would link the video somewhere up.
Yeah.
You can find the link.
So those are
Uh,
good learnings. Yeah, those learnings don't help us now because now we have a proper server. So that again, so that was at a time we couldn't afford a server. 1 lakh was too big of an expense for us.
hmm.
Not 1 lakh, probably 2 lakh. 2 lakh plus the cost of SSD, so it comes to around 3 lakh. At that time, we couldn't spend rupees 3 lakh on
Yeah.
this when we didn't know the benefits out of it. That would have been too big of a risk to spend. Then later, when we knew ki okay, doing it like this will definitely save a lot more than 3 lakh. Then that is the point we felt confident. Okay, now let us spend 3 lakh on it. Then we spent on it, got the server, things became easier, did everything in office. Then we realized, okay, nahin, having a lease line to office quality is not good. We need a data
Well,
center. So then we
yeah.
shifted to data center. And since then, we haven't looked back.
And right now you are playing that role of being a sysad for this whole
Right
thing.
now, I'm playing the role of being a sysad.
I think even if you scale up, right, you were talking about maybe 100 or 200 developers, which is quite far given that you are at 5 developers right now.
Yeah.
Wouldn't it be a lot cheaper to just hire a few folks who are extremely good sysads and pay them salary, but all of this is managed and that's going to be net positive with respect to the cloud costs?
See, that's definitely one thought. We will definitely try to do that first. The thing is, this is not our core business.
Yeah.
That's one very important thing to keep in mind, right? We can't delve too deep into it, forgetting अच्छा भाई, our business is actually creating metaverse experiences. This is all sidelined, right?
But not exactly right, because this is a classic build versus buy decision. And if there is financial sense into it, yeah, you have to spend some bandwidth, because if you have a team of, let's say, 3 or 4 sysads overseeing this, then there has to be some management bandwidth that goes into managing them, etc. So that is the cost that you have to pay apart from the money. But it is a classic build versus buy decision. And if like companies and giants like Flipkart is sticking to it, Dropbox moved away from S3 and they saved like
Most large
100
companies
billion.
do it. That's what I'm aware of. Most large companies do it,
But at a
right?
small scale, you're saying whether it
Uh,
is worth it.
Small scale, I haven't seen a lot of people doing it. I think whoever I've told to has cursed me. What are you doing? Why are you wasting your time?
How did this play out in the COVID times? Because if everything was on desktops and then people suddenly stopped coming to the office,
Hmm.
they were no longer connected to your LAN. How did that experience go? Like, did you have to get a static public IP and then expose everything over a VPN, or how?
So we were very lucky in that sense. Just before COVID, I think we had shifted everything to the data center,
Oh, wow.
right? And the reason for the shift was not COVID or something. The reason for the shift was QA, right? It was basically making sure the internet connectivity to
Hmm.
our services. Internet is not the reason we are not able to connect to our service. That was
Hmm.
the reason. Okay? Because no matter what
Okay.
we did, even though we had a lease line, so we had an office in Kasturi Nagar, everything was being dug up everywhere in Bangalore. Yeah, मतलब the lease line used to get cut every month.
Yeah.
यहाँ digging हो गई, वहाँ digging हो गई. This was a proper lease line. It wasn't a normal internet connection. It was a lease line. We were
Hmm.
paying a bomb for it, and even that had bad connectivity. So that's when we decided, okay, we do not have the capability of hosting a proper server in the office, thanks to the internet conditions and power conditions in India. So
Hmm.
we should use a data center, sanity prevailed, and we said, okay, we'll rent a data center. So we shifted all of this to the data center. We ended up saving cost because the money we were paying as internet bill and the money we were paying as a power bill, our rent is less than that.
This completes the first part of this podcast where we discuss the self-hosting journey of GMetri. Next week, in the second part of this podcast, we discuss the software challenges that GMetri faced in the metaverse space, which was quite early in 2017 when GMetri started. Thank you to 10x Eng for sponsoring this video. They are building a solution to make the alerting and monitoring more automated, easy, and centralized. Do subscribe to the channel if you like the content. See you.